to edit the video to make me look dumber than I actually am, okay? You can make me look as dumb as I am, but not dumber than I actually am. That's the only condition. So, so we're asked to solve this thing, and you can use the quadratic formula, but I'm going to try and factor it. And I call this the AC method of factoring because I'm going to head and multiply A times C. So what goes in the top right here? 105. And what's B? Negative 22. So check it out. What's 3 times 35? That's A times C. And this is B. Remember, in a standard quadratic, right? The coefficient of the square term, the quadratic term is A. The coefficient of the linear term is B, and the constant is C. So I have A, B is negative 22, and C. Now, I have to come up with factors of 105, two numbers that multiply to give 105 but add up to give 22. And to be honest, you're better off looking at this. 35 is 5 times 7, right? You guys see that? 1, 3, 5, 7. Those are the factors of 105. In fact, they're all primes, right? Well, right, 1, 3, 5, 7. I like to look at the 1 because sometimes that's useful. Well, I have to play with those and find out which ones can give me 22. So, for example, if I look at 3 and 35, if I add them, I could get, 38? If I subtract, I could get 32. I need to get negative 22. Does anyone know what the two factors are we're going to use? What? Does anyone know? Negative 15 and negative 7. So if I'm using these two, right, the other ones have to be a 7. So he's saying negative 15 and negative 7. All right? So sure enough, when I multiply them, I get 105. When I add them, I get negative 22. Since I can find those, this is factorable, and I can proceed. The next thing I do is I'm going to rewrite the linear term, this term right here, breaking it up into these two pieces. So this becomes 3x squared minus 15x minus 7x, my bad, 7x plus 35, and that has to equal 0. All that I did again was I rewrote negative 22x, it is negative 15x and minus 7x. Now we deploy the method we call factoring by grouping. We're going to look at the first two terms, and we're going to look at the second two terms, right? And we're going to pull out the greatest common factor of each. What's the greatest common factor of the first two terms?
3x.
So when I pull that out, right, divide both of them by 3x, what am I left with?
X minus 5.
That's right. This next one's a little tricky, right? When I pull out, what is the GCF of the next two terms? Yeah, it's 7, but you're right. We need to pull out a negative 7. So we're going to divide both. Whoops. I'll need that later.
That's why you need the string.
Later. Yes, because if I drop the pin, there we go, no problem. If I pull this out, negative 7, what am I left with? Divides negative 7x by negative 7, we have x. 35 divided by negative 7, minus 5. Which is so happy because let's check this out. What's my common binomial factor? So I bring the x minus 5 out in front, and what am I left with?
3x minus 7.
There we go. You were right, they were both positive, whoever said that. So, the only way one can get an answer of 0 via multiplication, right? I'm multiplying two things and getting an answer of 0, is if one of them 0. And I let them both have a term, right? If this is 0, right, that means x is equal to what? There's one of my answers. If this is equal to 0, that means x is equal to what?
7.
Well, 3x is equal to 7, and x equals 7/3. So there's my other answer. You get what I'm saying? All right, very good. Thank you. That's great. Very nice of you. Trim that up.